Good morning to everyone joining us today. My name is Catherine Hirsch. I do marketing, PR, and events at the Eclipse Foundation. And today I have with me Manoj, Palat, who will be doing a webinar session for us around Eclipse Neon, the release which is coming out on June 22nd. He'll be telling us a little bit about the Eclipse Neon and beyond, the JDT perspective, as he's called it. And he'll be giving us a bit of context into what kind of features we should be looking out for June 22nd. A bit of background on Manoj as well. He is an Eclipse JDT Core Project member, committer, has been working with IBM and Eclipse for about 3 years now. He's worked with companies of all sizes, large, all the way down to startups and smaller organizations, and he holds a master's degree in computer science. So for questions, if anyone does have questions, we have Eclipse Neon, hashtag Eclipse Neon, available as a Twitter hashtag that you can send us questions. We'll try to respond during the session. If we're unable to, we will get back to you and we will relay those questions to Manoj. Otherwise, you can send other questions to marketing@eclipse.org, or you can join the Q&A session here. So without further ado, I'm going to turn it over to Manoj to do his presentation on JDT.
Thanks, Catherine, for the wonderful introduction and for hosting this webinar. Good morning, good afternoon, and good evening to all of you who are listening at various times this presentation. In this talk, I'll cover the Eclipse Neon and beyond from a JDT perspective. This talk will have two parts. The agenda can be divided into two broadly. That is, the first part will be covering the new and noteworthy features of Eclipse Neon from a Java developer's perspective. And in the second part, we'll talk about the support we have for the new kit in the block, which is Java 9. Again, from a Java developer's perspective. The detail of this agenda is as follows. The first part will talk about the Java editor, the changes in the Java editor in Neon. We have the new features in Java views and commands, the features in compiler, the enhancements in null analysis, the additions in Java formatter, as well as a couple of features in debug and JUnit. The second part I'll be covering Java 9, a few introduction to the Java 9 concepts, as well as the module concepts and the module info.java file. Then we'll be rethinking about the model. We'll talk about the compiler changes. We'll do the impact analysis on other submodules like content assist, and we'll take a peek at the near future as to what we can expect for the Java 9. The first part I plan to cover through demos, so let's get into the demo right away. The first feature in Java editor is the code completion. So let's say we complete the code of the new, and you can see that the text new is highlighted in all the proposals. Continuing further, the next feature is also about code completion. So let's complete after type. You can see that the type appears anywhere in the proposals, not just the prefix. This is the substring pattern matching capability of Neon, the content assist. There are two additional templates that have come up in if, which is the next feature. So let's say we complete at if. There are if not null and if null templates. The conditional variable is a last seen variable. In our case, is the AST. The next one is the refactor rename option. So let's say we do a refactor rename. There is a new drop down that has come up, which will do an open rename dialog. And here you have two sub options, one to rename the getter and another to rename the setter. So let's say we rename to something like my name, and to preview, see that the get name has been changed to get my name. So press OK, and here you go. When the set name has been changed to set my name. This section is about Java View. The first feature in the Java View is about creating a new fields from method parameters. Let's say we have a constructor X with parameter string name and age. If you bring up the quick assist, press Ctrl 1, there is an option called assign all parameters to new fields. Click on that, you can see that two new fields, name and age, have been created. In addition, the assignments to them has also been done. The next feature is about removing redundant type arguments. Starting from 1.7, we are aware that these type arguments are redundant for instantiations. Neon provides you a way to set the preferences so that these get removed during code cleanup. So if you bring up the preferences under Java code style cleanup, you have a active profile, this which I created for the demo. If you edit that under unnecessary code tab, you have a sub option to remove redundant type arguments 1.7 or higher. We'll leave it checked and get back to the code. To apply this, you need to go to source, cleanup, and say next and finish, and the type arguments are gone. Next feature is about search. Neon provides you a multi-selection search. So let's say we have this class called completion proposal collector. If you go to the definition and bring up the outline view, which lists the fields and constructors, etc. Let's select a few constructors and right click, references, search for references in workspace. This will work with Ctrl Shift G as well. Here you can see that the results are available under the search view. Any of the, it searches for all of them or any of the constructors. Better still, you can select these constructors, do a further search. Let's search for declarations in workspace, and you get the result. So moving back to the code, another small option we have is Control Shift V, which opens the type from the clipboard. Let's say we copy the tree map to the clipboard, Control C. Then if you press Control Shift V, it opens up the tree map class. The next feature is about adding meta annotations. Let's say we want to create an annotation. Let's bring up the wizard and here give a name, annotate. Here you can see that you have option to add meta annotations like retention, target, and documented with their options and when you create this annotation. I will leave this as default. Let's create one. You can see that the annotation has been created with a proposed meta annotations. Moving to the next two features is about the grouping of reference libraries in Project Explorer. You can see that there is a container called reference libraries under which the reference libraries are listed. This container is shown because you have an option here to show the reference libraries node if you drop down from the Project Explorer. You can also, if you have the empty reference libraries, say in this case, you have an option to customize the view and filter the empty library containers out. OK, and here you can see that it's no longer visible. Okay, now we come to the compilers. There is one addition in terms of the severity level. Here you can see that under the problems there is something called infos, which is a new severity level, which says the value of parameter I is not used. That is an info. If you want to configure it to something else, you can bring up the quick assist, Control 1, and configure problem severity. Here you have the drop down to make it an error or a warning, or you can simply ignore the same. This section is about null annotations. You can now configure annotation-based null analysis to use multiple sets of annotation types. So let's see what it means. So you go to Properties, go to Java Compiler, Errors and Warnings, and make sure you have enabled the annotation-based null analysis. And here under Default Annotations for Null Specifications, click on the Configure, and you can see that you have primary annotations as well as secondary annotation support. This is relevant if your project uses third-party libraries that already use null annotations in their API, where the annotations used in a library may be different from those used in the current project. You can add your own annotations here. For example, let's try adding one non-null annotation, say edu.tcs. The quick assist works here like this, and here you go. Sorry, no. So that's one of the features wherein you can add arbitrary number of secondary annotations. You can add even more. So in the interest of time, let's stop at that. Next one in the null analysis is the pessimistic analysis for free type variables. So let's consider this free type variable t. The null analysis extends to do a pessimistic analysis so that it allows clients to instantiate a generic class with either a non-null or a nullable type. If it has to allow that, the implementation of the class must account for the worst in both the directions, non-null as well as nullable. So, to anticipate a non-null type, each field typed to a free type variable t should be initialized with a non-null value, which in this case is not, and hence you get the error. The field may not have been initialized, whereas its type t is a free type variable that may represent a non-null type. Similarly, wherever t is used, there has to be a non-null entity, while in this case the return value is null. Where t is considered to be non-null, you again get a null type mismatch error for type annotations. To the other extreme, every nullable element, in this case t is analyzed to be nullable, should be protected with a null pointer check. If not, you get this error, potential null pointer access. This expression has type t. It may represent a nullable type. All these options can be configured. In the configure problem severity level, you go down, you have the problems detected by pessimistic analysis for free type variables. You can change it to error, info, or ignore as per your wish. Which brings us to the next one, that is the option just below that, which is the unsafe non-null interpretation of free type variables from library. So let's go to that next. The next improvement concerns the consumption of generic types from a library, specifically invocations of library methods whose return type is given by a free type variable. In the above example, both list as well as map provide non-null type arguments, and hence the return type of both list and map are interpreted as non-null. For list, this is desired. For map, this is a bug. The analysis cannot see whether an absence of a null annotation for such a return type is intentional or an omission that should be fixed. For that reason, a new warning has been implemented to alert about this. So let's say you click on this, you get the new warning, unsafe interpretation of method return type is non-null. for both the list as well as get. This is as of now put as an info. You can configure it to move it to warning or error. Well, interested in getting onto null analysis? Want to use null analysis? Then here is a quick fix to add non-null and start off. Let's say you have an error which says potential null points to access. One option is enable null analysis. Use the quick fix command. Declare O as non-null to see the root problem, and you can save, and you can see that there is it points to the real problem. So adding non-null may not really solve your problem, but it definitely help you to start and provide with a hint on how to do the on where the problem could lie. Now this section is about the formatter, so let's bring up the formatter. So you have the properties here. This is a formatter for demo purposes. The first one is about subsections under line wrapping. Under this you have the expressions, you have assignments and conditionals. So let's go to assignments. Once you have the wrap policy in place, you can wrap before the operator. Similarly for conditionals also, the wrap before operator is enabled. It's a new option. For the for statement, you can decide the wrapping policy for the first element as well. Moving on to the indentation tab, you have a new option to format the fields separately if they fall into different groups. So let's say you can see that once you click on this, these two get formatted in one way, these two get formatted in another way. So that's about the alignment option. In the new line section, you can insert new line after annotations on enum constants. Now, pretty recent change that has come up is the addition of parentheses along the lines of braces. So parentheses is a new tab, and you have multiple options for multiple constructs like declaration, method invocation, annotation, lambda declaration, etc., etc. So you can play around with all these different options and sub-options. So one particular option, sub-option which I would like to highlight is the preserve positions, which can be used if you want to manage your wrapping of the parentheses manually. This section is about debugger. Pretty interesting scenario where you have two projects, say 6A and 6B. They have identical structures. Both have package P1. Both have X under package P1. Let's go to package P1X under 6B, B for breakpoint. Put a breakpoint at line number 5. Debug this application, and it opens up the debug support and stops at breakpoint 5. No surprises, no problem. Then let's go to the next project. Go to X, debug this, run as Java application. Surprisingly, it stops at line number 5, even though we do not have put a breakpoint explicitly anywhere for project 6A. So this is a kind of a bug or a feature, quite debatable, but anyway we do have an option. Now to make sure that this doesn't happen, we go to debug, Java debug, and there is an option to do not install breakpoints from unrelated projects. You apply that, then let's continue this and debug this again, and doesn't stop. It prints out the hello from 6A. The last item is about JUnit. JUnit assertions are enabled by default for the new JUnit configurations. So let's bring up the preferences under JUnit. You can see that the -EA option is enabled, and when you launch a new JUnit configuration, so keep it as it is. These are the assertions which are enabled. So if you run this as a JUnit, you can see that the assertion is hit because it's of course false. So that brings us to the end of the demo session of the first part. Okay, back to Java 9, the second part of the webinar. Java 9 has a lot of JEPs, Java enhancement proposals. The slide lists some of the important ones that affect the JDT. At the top of the list is Project Jigsaw, which defines a module system. We will see the module system in detail in the next few slides. In addition to proposing a module system, Jigsaw goes further to modularize the JRE itself, such that the Java 9 JRE can now be considered as available in a tailored format. That is, not everything gets into one big jar, but different pieces go into different modules. And as a developer, you can choose what you want to add for your programs. We'll not be covering all these details as this is primarily a JRE internal change. However, this change does affect JDT, and we'll get into those details later. Apart from Jigsaw, there are other additions such as Unicode, support for latest 8.0, milling project coin, which is a JEP 213. There are a few collection of enhancements, such as one is allowing private methods in interfaces, or disallowing underscore as a legal identifier, etc. Another change is the version string change. The Java 9 would be called 9 rather than 1.9. A minor change but affects in JDT code. Next, we'll see what a module system is. By definition, a module is what the slide shows. A module is a named, self-describing collection of code and data, and it offers reliable configuration and strong encapsulation. Well, this looks like a marketing talk. So let me define the module in my own terms. Practically, module is a concept for putting code in such a way that there is some access control. We can put a few packages in a module and selectively hide some of these packages. No extra effort for hiding anyway, but while selectively exposing some of the packages, we can export to a particular module we want to. That is a targeted exposing or a targeted exporting, as it is legally called, to some particular modules. A module can also declare what other modules are required by it, thus providing a dependency graph and also providing better access control. I would say it resembles a mini manifest file functions imposed in Java language directly. So, how do we define this module as it is in Java? With Java 9, we have a file called module info.java file, which is recognized natively by Java, or by the Java compiler itself. And with Java 9, we have new keywords that are recognized inside module info file. Not planning to cover all those, but just the basic ones in the stock. So we have a module called my_mod, and it has a few packages in it. We want to expose the package PQR to every other module and expose PQ to a particular module, that is your.mod. As shown in the slide, we use the exports keyword for exporting and to keyword to achieve a targeted export. And similarly, the dependency of this module is given by the requires keyword. So let's not worry about the public right now. The first statement states it requires java.base, which is the base module provided by JRE. and it also requires java.sql, just given by this last statement. The module info.java is not limited to just a source file. This file can be combined to produce a module info class as well. Which essentially means that there are compiler changes, there are grammar changes to recognize these keywords and the constructs following, and there are code generation changes to convert this module info.java to a module info.class. Let's compare the GREs from a Java 8 versus Java 9. While Java 8 GRE would have a list of jars, the Java 9 has a list of modules. One catch is that while jars have open format, the new format is proprietary. This can come in the form of JMajors or JMod files, but this comes with a list of tools and APIs of walkthrough or navigation through these files. So what does this all mean to the Eclipse IDE from a Java perspective or a compiler perspective? Well, as briefly touched upon earlier, this means that there are new grammar additions, new code gen. There is a concept for module path in addition to the class path. We need to support new formats. These are just the compiler modifications. From the larger JDT perspective, the module system may introduce a change in the model itself, which brings us to the project versus module concept. The project module interdependency is something which we are in the process of defining. Most of the model changes have direct dependency on this. Currently, one module per project is decided. There has been a proposal that discusses the possibility of multiple modules per project. I will share the link of that discussion towards the end of the presentation. There are issues of cyclic dependency and discoverability of the modules which are being worked upon. Should be ironed out in the next few discussions. With the basic concept, let's take a look at the impact of JDT as a whole. So we saw how the compiler is affected in some detail. Just to recollect, it involved grammar changes, module info.class generation, accessibility, etc. There's something called milling project con which has a few compiler changes as well. Model is affected to quite a large extent, especially with the introduction of modules and interdependency. This introduce an additional dependency and accessibility issues as well, which affect the lookup system. And the lookup system in turn affects the other systems, including search, content assist, etc. At this point, you don't have any changes from the DOM point of view unless there is a client-driven effort for or a client-driven request for an additional node or additional functionality. Well, these are the resources for which resources which you might find useful. Currently, the Java 9 support. Currently, we do have a Java 9 support. This is ongoing in a parallel stream, and we do have releases. We do package it periodically. You can install the Java. You can try it out in multiple ways. The easiest one is go to the marketplace, search for Java 9 support for beta, and install it in one of the latest Eclipse Neons. You can try it out in the Neon release itself, or you can download the p-bills which are available at this link, and you can take part actively for the. And the third one is, of course, you can go to the Java 9 beta Java 9 branch and download the latest code. If you want to take part in the discussions about module versus project concepts, and be a part in the decision making, please go to bug 4794883 and you can put in your comments there. So let me give you a brief demo of Java 9, and if you want to jump into Java 9 and convert a project in Java 8 to Java 9, we have an elementary migration support which you might find it useful. So let's get into the demo of that. In this short video snippet, I would show the Java 9 support, especially the elementary migration help provided by Eclipse Neon. So for that, you need to install the Java 9 support, which is in the beta state at this point of time for Neon 4.6. For that, bring up the Eclipse Marketplace, search for Java 9 support, and you get this option and install. In this case, I have it installed already. Then let's close this. Make sure that your Eclipse is running with Java 1.9, and there are a few steps which you can figure out from the site. Now let's assume that we have a project called test convert. At this point of time, it is running on 1.8 with the compliance of 1.8. It has two files X, two classes X, which has connection to X, and another class Y, which is RMI connection Y. It should be noted that these connection and RMI connection, etc., are now part of modules from Java 9 in Java 9. So let's start the conversion. Let's go to the properties of theory system library, change it to 1.9. Then make sure that your project compliance is 1.9. Okay, it's the same as the GRE, so it's 9. Open up new source folder. You can see that there is an option called create module info.java for 9 or higher. Make sure that you give the same name, that is SRC, to convert that folder into a Java 9, which essentially means just the creation of an elementary module info.java file. So we'll see what it means. So let's hit finish, and you get the module info Java file. It exports all the packages, P1 and P2, which are the packages inside that source folder. And it also says it requires base, Java.management, and SQL for the connection and RMI connection. So this is just to give you a start, and then you need to filter out the stuff like if you don't want to export P2, you need to cut it down, and so on and so forth. Please do note that this is a very elementary beta quality migration path. We hope to enhance this in the future. With that, we come to the end of the webinar. Thanks for your time, and back to you, Catherine.
Thank you, Manoj.
Yeah.
Thank you. Just before we sign off, I just wanted to let everyone know that we do have 6 additional webinar sessions coming up in the next 6 days. They will cover different topics relevant to the Neon release train, which again, like I said, is on June 22nd. The topics will cover JavaScript as it pertains to Neon, automated error reporting, PHP or the PDT project, JavaScript enhancements, Docker tooling, and user storage services and more. So do sign up for those sessions. we're getting a lot of expertise from different people who are very involved, and we'd love to engage with you. And again, thank you, Manoj, for joining us today. If there are questions, use the Twitter hashtag Eclipse Neon or send them to marketing@eclipse.org, or you can comment on our YouTube video. Thanks again to everyone involved.
Thanks, Catherine. Thanks, everybody. Bye.
Take care. Bye-bye.